All right, everyone. Thank you so much for coming to our symposium today. We've got, I think, a really fun mix of speakers from a lot of different areas that are trying to kind of collapse down these different scales of the brain into a single kind of story. So I think it should be fun today to try and walk through that together and hear from these different really interesting perspectives. So the sort of genesis of the idea is to start with this really archaic evolutionary conserved system, the neuromodulatory system of the brainstem and the forebrain, which is autonomously active when you wake up in the day and essentially projects out to the entire brain and douses it in neurochemicals that change the amount of communication between and within regions of the brain and can really shape the architecture of the brain. And so if you've been paying attention to neuroimaging in the last sort of 10 to 15 years, there's been this real focus on zooming out in the brain and trying to understand the sort of graph theoretical structure, or really the brain from a sort of very wide perspective, understanding how different parts combine into a larger topological structure. And what we'd really like to do today is to try to sort of collapse down those two viewpoints, right? Start from this extremely biological perspective of neurochemicals changing gain between circuits, and then think about that at the sort of really broad scale, both at how the brain looks with neuroimaging, but also in terms of behavior and the computations that might underpin behavior. We're also going to talk a little bit about nonlinearity. I absolutely love this. This is two lightning bolts colliding together. I'll show you again because it's so cool. So the idea that the brain is this inherently nonlinear system, right? We want to be able to track things. We want to say, if I raised up the potential by 1, I'm going to get an output of 1. And the brain is just fundamentally not organized that way. And there are different ways with computational modeling to try and sort of embrace that and try to understand where it can get you. The second thing is that the brain is inherently dynamic. This is a jellyfish getting caught in a ring attractor. The idea is that the brain can be thought of as this brain state that's getting pulled into these different states by phenomena that exist in its energy landscape. Rosalind in particular, but Michael as well, will talk about the computational benefits and how you can think about the brain in a sort of relatively abstract sense, and then relate that back to some of the brain imaging and principles that we'll see with the neuromodulation. And hopefully, fingers crossed, at the end of it, we'll come to sort of an emergent understanding. We'll be able to put all the parts together and hopefully get something that's more than the sum of their parts, to understand how all of these different systems can give rise to things like higher cognition. So with that, basically we're going to do questions at the very end. So we're going to try to go through the talks piece by piece. If you have any questions, please hold them from the end. And with no further ado, Michael Breakspear.